Okay, so let's see what is there in this question. An iceberg oscillates up and down in the sea with simple harmonic motion. At time t is equal to 0, the iceberg is at the lowest point of its motion. So it's kind of an extreme position, we can say. At this instant, its displacement is negative x naught relative to the equilibrium sea level. The angular frequency of the iceberg is omega. What is the velocity of iceberg at the time t? Okay, so this question belongs specifically to HL topic, isn't it? Okay, so it is at the other extreme. So first of all, we have to create this equation. The equation for the displacement will be x is equal to negative x naught. Because it is starting from the extreme, it will be cos omega t. Why? Because it is starting from the lowest point. So the cos omega t graph is like this, but the negative cos omega t graph will be like this. And so it is starting at the negative already. It is said here it is starting at negative, so it will be this graph. That is why I'm taking negative cos omega t. So this becomes the function for the displacement. Okay, now if this is the displacement, we have to find the velocity. So you must be good with calculus, otherwise you won't be able to do this. Although I think this is covered in the part of maths AAHL calculus, you should be able to differentiate it. Okay, so x is equal to, like, we want to find velocity, that will be dx divided by dt. So minus x naught will come just like that. Cos omega t, when differentiated, it will become negative sine omega t. Negative and negative gets cancelled out. Omega will come out because of the chain rule. This will be our solution. So B will be the correct answer. I don't think that you could be able to do anything other than this. Like you have to go for the calculus, because other than this, I don't think of any other method there. Or you can do one thing. You can just imagine that the velocity function will be sine. So this option is wrong, this option is wrong, and then you can just substitute the values. Like, let's say at t is equal to 0, the velocity should be positive. So t is equal to 0. Sorry, it is at the extreme position. No, yeah, it will be very difficult to imagine these kind of things. So I think this is the only method that I can suggest. Okay, dear students, if there is anything else that you want to say, you can message that in the comment section. Okay, dear students, all the best. Thanks for watching. Bye.